We are now looking at the opening screen for HEC-RAS. I have loaded in the Riffle Run Pool Glide sequence file. So let's take a first look at the cross sections. Section 10 is at the downstream end, and you can see it's simply a rectangular channel with a height of 10 feet and a bottom width of 33 feet. The downstream lengths are 0. Notice the Manning's end value has been entered, and any value can be entered for the overbanks. I have chosen 0.1. We have no overbanks here. And you'll notice that the stationing of the left and right top of bank have been entered. If I move up to the upstream end of the riffle, I have copied all these sections using the option where it says copy the current cross section. And then once I copied them all, I adjusted the elevations one at a time. So basically I only had to put in one section, and the rest of it was done by copying. The information for the elevation adjustment and the lengths came from the spreadsheet. So as you can see, there's section 20, 30. They're all rectangular sections. Section 90 is the one which we will be comparing it. This is the downstream of the riffle, which is 2 riffle run pool glide sequences away. Next, let's take a look at the boundary conditions. If I go to reach boundary conditions, we'll notice the flow rate is 300. I only need one flow location at the upstream end if the flow is constant. Now the reach boundary condition, I have a known water surface, and I have 102.34. That was a trial and error process. Let me show you. If I go over to a steady run, and I look at the files that I generated for the water surface. So every time I guessed a water surface, I would compare the water surface depth at section 10 and section 90. And when those two agreed, I knew that I had a complete solution. So you can see it took me a while. It's a number of different files on there. So I finally settled for 102.34. And here's what the profile looks like. Now these are all rectangular sections placed into the natural channel bottom profile. And now you'll notice that the velocity head, which is the distance between the water surface and the energy grade line, is fairly uniform. The slope of the water surface is fairly constant. This represents what's going on under bank full conditions. If we look at the profile summary table, we have our constant 300 cubic feet per second. We have our minimum channel elevation, the thalwag, as we've spoke about in the past. And then we have our water depth. So you see here, It was 102.34. It gives me a depth of 2.34. Now I go to section 90 and I take 104.02 minus 101.68, also gives me a depth of 2.34. That's how I know that I've achieved a repetitive flow sequence through the riffle, run, pool, glide sequence. If I wanted to, I could compute the water surface profile, I should say the depth. If I go to options, and it says define a table. And so I come into here, and I notice the word diff. And it says difference between the previous two columns. So I would like minimum channel and water surface. I will insert a column, and then I will put diff. And it works on a double click. So that allows me to have that table heading. I hope I can close this. It'll give me this warning message because it's going to give me a negative answer, which doesn't make any sense, but it'll allow me to look at this. So you'll notice the depth here, which is the difference between this column and this column. So obviously going to give me a negative answer, but it shows that my depth at section 90 is 2.34, and my depth at section 10 is 2.34. Notice I can add that column so that I don't have to do the subtractions in my head. You'll notice also we have the fruit numbers repeat. See, 0.45, 51, 32, 30. 45, 51, 32, 30. So I've achieved a repetitive sequence. Now, the reason we did this, we want to get some idea how the conveyance of the pool compares to the conveyance of the riffle. And you'll find if you look in the table, this is where you would get the conveyance information. See, the conveyance at section 90 is 3404. Let's go back to section 70, or 80 would be the pool. So we have 5275. So you see that the conveyance of the pool in this particular example is at least 50% greater than the conveyance in the riffle. The pool will have a much flatter friction slope, so it will be necessary for the pool to have a far greater conveyance. And we will talk about this in the upcoming video when we discuss actually the sizing of the pool.